We study the symmetrical and asymmetrical networks, right? So what is the difference between the symmetrical and asymmetrical networks, and different types of these T networks and pi networks, right? And in third unit, we study the filters, constant K filters, and M-derived filters, composite filters, and their design, right? The next, coming to the fourth unit, we have this attenuators and equalizers, right? And fifth unit, in this attenuators and filters, you study this how to design this T-type symmetrical attenuator, T-type equalizer, and bridge T attenuator, etc. Right? In fifth unit, you study the network synthesis. Okay, in this positive real functions and RC impedance functions, RC and RL admittance functions, etc. Right? So today we'll see this two-port network. So before going to this first unit, first briefly I'll review about the basics. What do you mean by network? Okay. Just hold on. Okay. Just briefly review about what are the network elements, and what is the difference between these. How many types of networks are there? Just hold on. Yeah. So these all those things you will study in the second semester, right? In basic electrical circuits, right? So once again, just briefly, I will review about this basics. Okay, what do you mean by network element? Okay, a network element, it is nothing but it is a component of the circuit with different characteristics. So there are two types of network elements. First one is the linear elements, okay, and second one is the non-linear elements, and the third one is active elements and passive elements. So these are the different types of elements. So in linear elements, if you see in linear elements, it shows the linear characteristics between the voltages and current. Okay, the examples for these linear elements are resistance, inductor, and capacitor. Okay, coming to non-linear elements. Okay, so here in non-linear elements, so in case of nonlinear elements, when the current passing through it, it does not change linearly with respect to the applied voltage. Okay, the examples for these nonlinear elements are transistors, field transistors, and diodes. Then it's coming to the active elements. So in active elements, if the current these elements are having the capability of enhancing the applied energy signal, applied signal, okay, by passing through it. Okay, these are called as the active elements. So the examples for these active elements are semiconductor devices. All semiconductor devices comes under these active elements. The next, coming to the passive elements. So these elements, they don't have the capability of boosting the signals. Means these elements, they don't have the capability of amplifying or increasing the strength of the applied signals. The examples are resistance, inductor, and capacitor. Okay. The next, coming to the just hold on. The next, unilateral elements. Okay, if the magnitude of the current passing through an element is affected due to the change in the polarity of the applied voltage, is called as the unilateral elements. Okay, examples are diodes and transistors. Next, coming to the bilateral elements. So what do you mean bilateral elements? Okay, if the current remains same, even the applied voltage polarity changed. Okay, these are called as the bilateral elements. Examples are resistors, capacitors, and inductors. The next, coming to the classification of networks. Classification of networks. Basically, these circuits are networks are classified into linear network and non-linear networks, bilateral and unilateral networks. So, what do you mean linear network? A circuit whose parameters or elements are always constant, irrespective of the change in time, temperature, etc., is known as linear network. So for this network, Ohm's law can be applied to that linear networks. Whereas coming to the non-linear networks, a circuit whose parameters change their values with change in the with change in time, voltage, temperature, etc., is known as non-linear networks. Means for these networks, Ohm's law cannot be applied. Then it's coming to the bilateral network. So what do you mean bilateral network? A network whose characteristics or behavior is same irrespective of the direction of current through various elements is called as bilateral network. Next, coming to the unilateral network. A circuit whose operation behavior is dependent on the direction of the current through various elements is called as unilateral network. Okay. Next, coming to the active network. A circuit which contains a source of energy is called as the active network, such as energy sources like voltage source and current sources. Next, coming to the passive network. A circuit whose which contains no energy sources are called as the passive network. Next, coming to the lumped network. What do you mean lumped network? A network in which all the network elements are physically separable are called as the lumped network. Okay, physically separable means, so if you see almost all the electric circuits, all the electric networks are lumped networks only, lumped in nature. Okay. Then next, coming to the next classification, that is distributed network. A network in which circuit elements are circuit elements which cannot be separable are called as the distributed network. Okay, the examples for this distributed network are transmission line. Okay, so here if you see in the transmission line, in transmission line where resistance, inductance, capacitance of the transmission lines are distributed throughout the along the length of the transmission line, means which cannot be separable. So these type of networks are called as the distributed networks. The next, yeah, is it clear? Different types of networks and elements. The next, coming to the today's topic, that is two-port networks. Yeah, two-port networks. So what is the port? A pair of terminals through which current may enter or leave the network is called as a port. Is clear? Two-port network. These two-port networks are having two separate ports. So a pair of terminals through which current may enter are called as a enter or leave a network is known as a port. So the two terminal devices, all the two terminal devices such as resistors, capacitors, inductors are examples of the single port network or one port network. Okay. The next, coming to the two port. A two port network is an electrical network with two separate ports for input and output. So it has two terminal pairs acting as access points. The current entering at one terminal of pair leaves the other terminals. This is the simple block representations of single port network and two port networks. If you see in the first figure, it is called as a one port network or a single port network. You see here only two terminals are there, right? Whereas coming to the two port network, in case of two port network, you see here you will find the four terminals. Just one minute. Okay, so generally a network is represented by a rectangular box. So a pair of terminals at which the signal may leave or enter to the network is called as a port. Okay, so so from this one, it can be defined as a pair of terminals into which energy is supplied or from which energy is withdrawn is called as a port. So a two-port network has only two pair of terminals. So one pair is at the input and the other one is at the output side, right? So if you see here in this diagram, this block representation, yeah. Okay. So the variables of these two-port networks are, you see this diagram, these variables, this is V1, I1 and input voltage and input current. At the output side, this is the output current and output voltage. So these variables of this two-port networks are V1, V2 and I1, I2. Okay. So two of these variables are dependent and the other two are the independent variables. Okay. With these four variables, the number of possible combinations with these four variables. So depending upon these possible combinations, these two-port parameters are classified into 6 types. Those are Z parameters, Y parameters, Z parameters, Y parameters, H parameters, that is hybrid parameters, G parameters, ABCD parameters and G parameters. Okay, the next. First we'll see the yes, is it clear? So out of these four variables, assuming so in case of this two-port network analysis, okay, we require two linear equations in terms of these four variables, right? So we can obtain these equations by considering two variables as the dependent variables, and the remaining two are the independent variables. Right? Now, for this Z parameters, yeah. So a network consists of only linear elements, and the linear relationship can be obtained. So by writing two variables in terms of the other two variables. So there are six possible ways of selecting these, selecting two independent variables out of four variables. So therefore, there are six different pairs of equations, um, different different equations, right? Such as impedance, that is, and admittance, and hybrid, and inverse hybrid, that is G parameters, and ABCD parameters, and inverse ABCD parameters. Yeah. So first one is Z parameters. Yes, is it clear or not? Any doubt here? Yeah, one of you please respond. Hello.
Yes, sir.
Right. Okay. Okay. So in case of two-port network, there are four variables. Out of these four variables, if you choose two variables as dependent and another two are independent, you may get the six possibilities, six combinations, right? Means six different types of parameters. That is Z, Y, H, G, ABCD, and G parameters. So first we'll see these Z parameters. Okay. So in this, these Z parameters are also called as the open circuit impedance parameters or simply impedance parameters. Okay. So these are obtained. These Z parameters are obtained by expressing voltages at two ports in terms of currents at these two ports, right? See here, these Z parameters are obtained by expressing voltages at two ports, that is V1 and V2, in terms of I1 and I2, that is currents at the two ports. That is, simply we can say that here V1 is the function of the I1 and I2, and similarly V2 is the function of I1 and I2. Okay. So as these are the uh, linear network, as the network consists of only linear elements, so the linear relationship can be obtained by writing these two variables as the dependent variables and other two are the independent variables, right? So now if you put it in the matrix form, we get like this, that is voltage matrix V1 V2, column matrix. Okay, okay. Before writing these equations, okay. Now, if you write these equations for this relations, that is V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 and plus Z22 I2. So the coefficients of these uh, independent variables, that is I1 and I2. So what are those coefficients? That is Z11, Z12, Z21, Z22. These are nothing but the Z parameters. Now, okay, if you write these in the matrix form, you will get like this. That is V1, V2 is equal to Z11, Z12. Yeah. Okay, just hold on. Okay, if you write this in the matrix form, we'll get like this. That is, V1, V2 is equal to Z11, Z12, Z21, Z22 into uh, uh, current matter. That is I1, I2. Right? Is it clear? Hello? Any doubt, ma'am? Any doubt here? And doubts in ma'am? Hello?
Yes, sir.
No, sir.
All right. Okay, ఇక్కడ ఏం లేదమ్మా, సింపుల్ చూడండి. So these, if you see here, in Z parameters, V1, V2 are the dependent variables and I1, I2 are the independent variables. Means simply we can say that V1 is the function of the I1 and I2 and V2 is the function of the I1 and I2, right? So these equations, if you put it in the equation form, these relations, right? If you write it in the equations form, that we will get it as V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2, right? So here in these equations, equation 1 and equation 2, these coefficients, that is Z11, Z12 and Z21 and Z22, these coefficients are called as the Z parameters, right? And if you write it in the matrix form, you get like this. That is V1, V2 is equal to Z11, Z12, Z21 and Z22 into I1, I2. Okay. Now we'll see how to find out these coefficients, that is Z parameters, that is Z11, Z12 and Z22. ఇది అర్థమైందమ్మా? ఇప్పుడు వీటిని ఈ పారామీటర్స్ ని హౌ యు ఫైండ్ అవుట్? దిస్ ఇస్ దిస్ ఈక్వేషన్. ఈక్వేషన్ చూడండి, ఇది ఎలా ఉంది? ఇది దట్ ఈస్ V1 is equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2, right? So here, if you want to find out this Z11, ఇది Z11 వాల్యూ రావాలంటే మనకి ఈ కోఎఫిషియంట్ వాల్యూ రావాలి అంటే have to make it this term I2 as 0. Okay, so if you substitute here I2 equal to 0, I2 equal to 0. Okay, I2 equal to 0 by making I2 equal to 0 by making I2 equal to 0. So what it means? Current zero means what it means? Current zero means simply if I2 equal to 0 means by open circuiting the output port. Current zero means simply open circuiting the output port, right? So that's why these Z parameters are also called as a open circuit parameters or open circuit impedance parameters or impedance parameters here. Yeah, when I2 equal to 0, V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z1 to I1, Z2 to I2. So by substituting I2 equal to 0, this term becomes 0, this term becomes 0. So therefore, Z11 equal to V1 by I1. How it looks like? This is nothing but a simple ratio of voltage by current. So voltage by current is nothing but the impedance. Okay, that is impedance. Okay, the units for this one is ohms. Right. Similarly, by substituting I2 equal to 0 in this equation, this term becomes 0. So therefore, Z12 that is Z21. Yeah. Yeah, just hold on. It's there is a small problem with my presentation. Again, I'm opening this. Okay, clear? By substituting this I2 equal to 0 in equation 2, I2 equal to 0 in equation 2, you will get this Z21 as V2 by I1. So this it is called as a open circuit forward transfer impedance. So why it is called as forward transfer impedance? Here this Z21, it is the ratio of the output voltage by input current. So that's why it is called as a forward transfer impedance. Right? Whereas coming to here Z11. Z11 is nothing but it is a ratio of the input voltage by input current. So voltage by current is nothing but the impedance. So here these subscripts 11, this 11 indicates the port 1 variable. So that's why it is called as a input impedance. Whereas here Z21 is nothing but the, it is a ratio of V2 by I1. So V2 by I1 is nothing but the, this V2 is the output port voltage divided by I1. That is nothing but the input current. So it is called as the open circuit forward transfer impedance. Right? Is it clear? That is V1 equal to Z11 I1 Z1 to I2, V2 equal to Z21 I1, Z2 to I2. Right? Now, this is equation 1, equation 2. So, by substituting I2 in equation 2, this term becomes 0. So, therefore, V2 equal to, we'll get this, V2 equal to, Z1 equal to V2 by I1. Then next coming to to find out these two parameters, that is Z12 and Z22. Okay, by making I1 equal to 0. So what it means? By making I1 equal to 0, I1 equal to 0 means simply by open circuiting the port 1. Port 1. By open circuiting the port 1. Open circuiting the port 1. So that is, so if you substitute I1 equal to 0 in equation 1, by substituting I1 equal to 0 in equation 1, so this term becomes 0. Therefore, Z12 equal to Z12 equal to Z12 equal to V1 by I2. So here Z12 equal to V1 by I2. So here, you see here again it is also the ratio of the voltage by current. It is also a impedance, but it is a reverse transfer impedance. Okay, so it is a ratio of the input voltage by output current. So that's why it is called as the reverse transfer impedance. The next coming to the fourth parameter, that is Z22. By substituting I1 equal to 0 in equation 2, I1 equal to 0 in equation 2, this term becomes 0. So therefore, Z22 equal to ratio V2 by I2, that is V2 by I2. So there is nothing but the output impedance. So if you see this, all these parameters, 4 parameters, these are the ratios of the voltage by current. So and the units for these all are ohms only. Right? Now, if you draw equivalent circuit, for this equations, linear equations, we'll get the circuit like this. That is V1 equal to I1 into Z11. Input impedance I1 into Z11 impedance plus Z1 to I2. Okay, this is one equation, and then it's coming to the second equation. This one, V2 equal to Z2 to I2 plus Z21 I1. Yeah. Yeah. Now, so based on these Z parameters, we'll do one sum. The next we'll go for the one or two sums, and then we'll go for the Y parameters. Okay. Note on the circuit. Find Z parameters for the given circuit. So that is so this is 20 ohms, this is also 30 ohms, and this is 40 ohms. Right? You find out the Z parameters. So what are those Z parameters? Can anybody answer? Hello? Even parameters are Z parameters. Z11 value, Z12 value, Z21 value, Z2. So you need to find out these all values. ఇది అంతా ఫైండ్ అవుట్ చేయాలి ఫర్ దిస్ నెట్వర్క్. So this is I1, and this is I2. Okay. So for this given circuit or network, first you write the Z parameter equations, that is basic equations, that is V1 equal to V1 equal to Z11 I1, Z12 I2, and V2 equal to Z2 I1, Z22 I2. These are the basic equations for the Z parameters, right? Right. Now need to find out the Z11, Z12, Z21, Z22, right? For this network. Now, so can anybody answer? How will you find out this Z11 and Z21? ఎలా ఫైండ్ అవుట్ చేస్తాం?
I2 is equal to 0.
ముందుకు వెళ్తాం. రైట్. సో ఎందుకు why we have to make it as I2 0? Why not V2 as 0? ఇది V1, this is plus minus, this is also plus minus V2. ఇక్కడ రెండు ఉన్నాయి కదా, I2 ఉంది, V2 ఉంది. ఇక్కడ ఇన్పుట్ పోర్ట్ సైడ్ కూడా two values are there, that is V1 and I1, two variables, right? V1 and I1. సో ఇవి రెండు ఫైండ్ అవుట్ చేయాలంటే this one and this one, why we have to make it as I2 as 0? Why not V2 as 0?
To get to Z11.
అదే ఎందుకు, అదే Z11, Z21 రావాలంటే I2 ఎందుకు 0 చేయాలి? హలో చెప్పండి, తెలిసింది చెప్పండి. మీకు ఇందాక స్టార్టింగ్ లో చెప్పాను, జెడ్ పారామీటర్స్ ఆర్ నథింగ్ బట్ ది లీనియర్ సర్క్యూట్ కాదు. జెడ్ పారామీటర్స్ ఆర్ నథింగ్ బట్ ది ఓపెన్ సర్క్యూట్ ఇంపిడెన్స్ పారామీటర్స్. ఓకే. సో ఇఫ్ యూ మేక్ ఇట్ దిస్ I2 as 0, ఈ I2 అంటే కరెంట్ 0 అయితేనే మనం యూ కెన్ సే దట్ ఇట్ ఈస్ ఏ ఓపెన్ సర్క్యూట్. ఓపెన్ సర్క్యూట్లోనే కరెంట్ 0 ఉంది, రైట్? అంటే సో ఇవి రెండు పారామీటర్స్ ఫైండ్ అవుట్ చేయాలి అంటే ఇఫ్ యూ మేక్ ఇట్ as output as open circuit, you will get these two parameters, that is Z11 and Z21. Similarly, ఇవి రెండు పారామీటర్స్ కావాలంటే యూ హావ్ టు ఓపెన్ ఇట్ ది ఇన్పుట్ పోర్ట్. అర్థమైందా? అందుకనే వైల్ ఫైండింగ్ ద జెడ్ పారామీటర్స్, కేస్ 1లో I2ని 0 అని అజ్యూమ్ చేసుకుంటాం, ఇది ఓపెన్ సర్క్యూట్ పారామీటర్స్ కాబట్టి. దెన్ విల్ ఫైండ్ అవుట్ దీస్ టూ, Z11, Z21 ఫైండ్ అవుట్ చేస్తాం. అండ్ సిమిలర్లీ ఇవి రెండు ఫైండ్ అవుట్ చేసేటప్పుడు దెన్ పోర్ట్ 1 కరెంట్ని 0 చేస్తాం, అంటే పోర్ట్ 1ని విల్ మేక్ ఇట్ యాజ్ ది ఓపెన్ సర్క్యూట్. అర్థమైందమ్మా? ఇట్స్ క్లియర్? అది లీనియర్ అన్న వాళ్ళకి ఇది ఆన్సర్, రైట్? లీనియర్ కాదమ్మా ఇది. రీజన్ ఈస్ ది జెడ్ పారామీటర్స్ ఆర్ ది ఓపెన్ సర్క్యూట్ పారామీటర్స్. ఓకే. సో ఓపెన్ సర్క్యూట్ కాబట్టి కేస్ 1లో వచ్చేసి ఒకసారి ఇది I2 0 చేసుకుంటాం. I2 0 అంటే ఏంది? బై ఓపెన్ సర్క్యూటింగ్ ది పోర్ట్ 2. Okay, by making I2 equal to 0. By making I2 equal to 0 means by open circuiting the port 2, right? And if you redraw the circuit, ఇది కనుక మనం రీడ్రా చేస్తే మనకి ఇలా వస్తుంది. ఈ పోర్ట్ 2ని ఓపెన్ సర్క్యూట్ చేసి రీడ్రా చేస్తే సర్క్యూట్ ఇలా ఉంటుంది, ఈక్వలెంట్ సర్క్యూట్. This is ఇది మీరు కొంచెం నీట్గా డ్రా చేసుకున్నాం ఇది. యాజ్ ఐఎమ్ రైటింగ్ ఇన్ ద స్లైడ్, ఐఎమ్ నాట్ getting properly, I'm not writing properly, right? This is 20 ohms, this is plus minus, okay, this is 40 ohms, and this is 30 ohms. So ఇప్పుడు I2 0 చేసాం, this is 0, ఇది V2 ఇక్కడ ఉంది, ప్లస్ మైనస్ ఇది, రైట్, ఇది I1. So this is the equivalent circuit, right? So this is I1. Now for this one, so I2 0 అయితే from this equations, from equations 1 and 2, when I2 equal to 0, you will get this, అంటే ఈక్వేషన్స్ 1 and 2, ఇవి I2 0 అయితే ఇది ఈ రెండు 0 అయిపోతుంది, ఈ రెండు టర్మ్స్ 0 అవుతుంది. సో therefore Z11 equal to V1 by I1 and Z21 equal to Z21 equal to V2 by I1. This is when I2 equal to 0 and this is when I2 equal to 0, right? So to find out the Z11, you need to find out V1 value and I1 value, right? So therefore now if you write the KVL, దీనికి KVL రాస్తాయి, ఇన్పుట్లో KVL రాస్తాయి. KVL రాస్తే ఏమవుతుంది ఇది, see here, minus plus 20I1 plus 40I1 Can anybody read out this KVL equations for this mesh 1? మీకు వచ్చింది చెప్పండమ్మా, మీకు అర్థం కాదా లేదని మళ్ళీ రిపీటెడ్. హలో,
ఎస్ సార్.
మెష్ ఈక్వేషన్స్ వచ్చు కదా మీకు, ఆల్రెడీ ఫస్ట్ ఇయర్లో సెకండ్ సెమ్లో నేర్చుకున్నారు, చెప్పండి. దీనికి మెష్ ఈక్వేషన్స్, ఇది రెసిస్టెన్స్ కాబట్టి ఇది ప్లస్ మైనస్ అవుతుంది. యూ టేక్ ద కరెంట్ డైరెక్షన్ లైక్ దిస్,
I1 minus 10
20I1
minus 10 into I1 minus I2
minus this is 40, this is not 10.
Okay, 40
చెప్పండి రీడ్ అవుట్.
20I1 plus 40 into I1 minus I2
minus I2, right, good,
is equals to
and one more thing, just wait, hold on. Just small mistake అది, 40 into I1 minus, is it I1 minus or plus? See the current direction.
Yes, sir.
ఇది ఈ డైరెక్షన్ లో ఉంది కదమ్మా, అందుకని I1 plus I2 is equal to నెక్స్ట్. ఎందుకు ఎవరు చెప్పారు ఈక్వేషన్, దట్ ఈస్ నాట్ మైనస్ అన్న ప్లస్, ఎందుకంటే if you see here I1 and I2 in the same direction, so therefore you will get the 40 into I1 plus I2 is equal to, yes, complete it, V1. So therefore if you simplify this one, 20I1 plus 40 into I1, what about I2? I2 is 0, so it means this becomes 0, as port 2 is open circuited, means I2 is 0, so therefore 20I1 plus 40I1 is equal to V1. It's clear? 40I1, as I2 is 0, as port 2 is open circuited, so therefore V1 equal to 60 I1. So therefore, my constant ratio V1 by I1 is equal to 60 ohms. So this is nothing but the Z11. Is clear? Hello?
Yes, sir.
Right. The next, coming to the,
రెసిస్టెన్స్
అర్థం కాలేదండి.
Z11 రెసిస్టెన్స్ కాదు సార్, ఇక్కడ ఇంపిడెన్స్ ఎట్లా అవుతుంది?
Z11 ఎక్కడుంది Z11?
రెసిస్టెన్స్
See this ratio. What is this ratio? Z11 equal to, it is the ratio of V by I. So what are the units for this voltage by current? It is nothing but the
Resistance.
impedance, resistance or impedance, right? So the units for this one is ohms only. Clear? The next, coming to the second parameter, that is Z21. So to find out the Z21, it is a ratio of V2 by I1. అంటే మనకి ఈ రెండు వాల్యూస్ తెలియాలి. V2 వాల్యూ తెలియాలి, I1 వాల్యూ తెలియాలి. So how will you find out V2? V2 is nothing but it is the drop across this terminal, right? So therefore V2 equal to, how will you find out drop across this terminals? Here, as it is 0, I2 is 0, there is no current flowing through this resistance, means there is no drop here. So whatever the voltage we are getting here, same voltage we will get at these points also. So therefore V2 equal to 40 into the current flowing through this resistance, that is I1. So therefore V2 by I1 is equal to 40. So that is nothing but the Z21. Is clear? Hello? Okay, now I'll stop here. The next class we continue. Just hold on, I'll take the attendance.